Students, last time I have discussed with you difference between the physioption and chemioption. Okay, so now today I am going to discuss with you factors affecting adsorption, and then after Freundlich isotherm and some points of Langmuir isotherm. So try to understand factors affecting adsorption. First nature of gas. As you know, last time I have also discussed with you gases which easily liquefy. Gases which easily liquefy get easily adsorbed. For example, CO2, HCl, NH3 is more easily adsorbed, in comparison to helium, O2. Okay. Second is surface area. All of you know very well surface area is another factor that affect the adsorption. More the surface area of adsorbent, more the surface area of adsorbent, more adsorption. You can illustrate with example here. This is a block of platinum in which hydrogen gas to be adsorbed, and this is the another platinum block. Here is also. So you can imagine simply that which platinum block adsorbs maximum amount of hydrogen gas. Okay, so now after the surface area, temperature. Temperature is another factor that affect the adsorption. Students, if we talk about the physioption. In physioption, this is the temperature, amount of gas. This is the temperature and this is the amount of gas. So the graph is always this. As the temperature rises, adsorption decreases. As the temperature rises, adsorption decreases. In chemioption, chemioption, physioption. in chemioption here, this is the temperature, this is the mass of gas. So here initially increases, and after the maximum temperature it becomes constant, because this temperature helps to increase activation or intermediate form is easy. So this is the another factor, that is the temperature. This is for physiopson and this is for chemiopson. Here always decrease with rising temperature. But here always increase. Here initially increase, and then decrease. Okay, so finally you can also understand about the effect of temperature over the adsorption. Now the next one is the pressure. As you know very well, pressure in both cases, either physiopson and chemiopson. Increase adsorption, but up to a limit. Students, you can understand that with the graph. This is the pressure, this is the amount of adsorbed material. This will increase, but at a certain point, constant. Initially increase, but after a certain point it becomes constant. It means this is the maximum pressure. This is the maximum pressure and maximum adsorption. Now beyond this pressure, no effect of adsorption generally takes place. Okay students, now the next, the effect of pressure is also explained by effect of pressure is also explained by Freundlich and Langewehr, LANG MUI length. But in your syllabus, only Freundlich isotherm is given. Only Freundlich isotherm is given. So now I am going to define the Freundlich isotherm. Okay, so try to understand what is the Freundlich isotherm. Freundlich isotherm. Freundlich, Freundlich. Freundlich isotherm. He explained the effect of pressure. The effect of pressure he explained the effect of pressure over the effect of pressure on adsorption. Effect of pressure on adsorption. He proposed that if X mass of adsorbate adsorb over m mass of adsorbent, if X mass of adsorbate adsorb over m mass of adsorbent is directly proportional to the pressure. Okay, so X upon n is directly proportional to P to the power 1 upon n. X mass of adsorbate adsorb over the m mass of adsorbent is directly proportional to the P upon n. P to power 1 upon n. So X upon n is equal to K into P to the power 1 upon n. So on taking log, we get that log X upon n is equal to log K plus 1 upon n log P. 1 upon n log P. So I think all of you get it. Freundlich isotherm. Freundlich proposed that X mass of adsorbate, that is adsorb over the m mass of adsorbent, is directly proportional to the pressure of the gas. So here X upon m is directly proportional to P to the power 1 upon n. So you know X upon n is equal to K to the power 1 upon n. K is the proportionality constant. K is the proportionality constant. K is the proportionality constant. So here on taking log, we get log X upon m is equal to log K plus 1 by n log P. Okay, now we can plot a graph with the help of this equation. Must remember that this all happen at constant temperature. The sentence is given for the constant temperature. So here, as we know, log x upon n is equal to log k plus 1 upon log p. So y is equal to mx plus c. Y is equal to mx plus c. Now log x upon m, this is the log p. So this is the c, intercept log k, and m is equal to 1 upon n. Okay, so this is the graph related to the Freundlich isotherm. You can also, this is the theta, this is the perpendicular A, this is the V. So we can write here tan theta is equal to perpendicular upon base. So A upon B is equal to 1 upon n. Okay, so tan theta is equal to 1 upon n. This is the slope. Okay, so this is all about the Freundlich isotherm. I think all of you understand. Freundlich isotherm is given for the effect of pressure on the adsorbent. As you know very well, when we raise the pressure, the adsorption becomes faster. So Freundlich proposed that the mass of x adsorbent over the mass m is directly proportional to the pressure of the gas. So x upon m is directly proportional to the p to the power 1 upon n. You know this 1 upon n explains the limit of the adsorption. So here x upon n is directly proportional to p to the power 1 upon n. X upon n is equal to k p to the power 1 upon n. K is the proportionality constant. On taking the log of both sides, you will get that log x upon m is equal to log k plus 1 upon n log p. Okay, so we can also plot the graph with the help of this equation. We know that log x upon m is equal to log k plus 1 upon log p. Students, here y is equal to mx plus c. This is the straight line equation. So we put here the log x upon m on y-axis and log p and x on x-axis. And when we draw the graph, you know it is the straight line, but the value of c is given log k, so we put here log k. This is the intercept. And m is equal to 1 upon n. You know very well, we can take an intercept with small portion for measuring the effect of pressure on it. So here tan theta is equal to perpendicular upon base. So a upon b is equal to 1 upon n. So tan theta is equal to 1 upon n. Now there are three conditions to explain the effect of pressure. Try to understand. I am going to raise it. Try to understand. Students, if first condition, so students, here is the three conditions. First, if the pressure is very low, so you know x upon n is equal to k into p 1 upon n. If the pressure is very low, it means the value of 1 upon n is equal to 1. 1 upon n is equal to 1. So initially increase adsorption and then constant. Okay, first condition. Second condition is is that if pressure is very high, pressure is very high. So you know when the pressure is very high, it means 1 upon n is equal to 0. 1 upon n is equal to 0. So x upon m is equal to k into 1. So here no effect of pressure. No effect of pressure on adsorption. No effect of pressure on adsorption. And the third condition is intermediate pressure. Intermediate pressure. The value of 1 upon n is between 0, 1. So these are the three conditions regarding to the effect of pressure on the adsorption. Now student, another good concept is given in NCERT. So try to understand this concept. I think it's very important concept which given in the NCERT. So try to understand. Students, there is a graph that given in your NCERT. This type. This is the pressure. This is the temperature, and such type of notice. Consider this is the T1, this is the T2, this is the x upon m. So which is larger, T1, T2 or T3? Which one larger? Try to explain it. Student, for explaining this concept, we make a perpendicular line on y-axis. As you know, on rising temperature, this is this temperature, this is this temperature, and this will take this temperature. So, student, here you can see that temperature and x upon m. Temperature is directly, the temperature is inversely proportional to the x upon m. You know very well, if the temperature increases, then the adsorption decreases. So you can understand that the T1, the adsorption at T1, the adsorption at T1 is lesser than in comparison to T2 and T3. So which is the larger temperature? So larger temperature is the T1, is more than T2 and T3. As the temperature rises, the rate of adsorption decreases. As the temperature decreases, the adsorption increases. Okay, so this is all about the Freundlich isotherm. I think all of you understood about the Freundlich isotherm. Again, try to state in this type of graph. This is the pressure. This is the x upon m. That is the amount of adsorbate that adsorb over the adsorbate, and the temperature is given to you. So you can select that which temperature is more, for the particular slope. So T1, T2 and T3 is given. So how can you select that? You know very well that we put a perpendicular line on pressure and then correlate the temperature with x upon m. So you know very well, as the temperature rises, the rate of adsorption decreases. So T1 is greater than T2 and greater than T3. Such type of question is asked in the JEE Mains and Advanced. Okay. Now the next thing is that adsorption in solution phase. Adsorption in solution phase. Adsorption in solution phase. in solution. Okay student, I will discuss this topic in the next lecture.